Alright, this lesson is on the quadratic formula and the discriminant, which is part of the quadratic formula, and simplifying I raised to any power. But first, let's start by looking at simplifying radicals that have a negative number underneath them. Alright, you can't take the square root of a negative number. So they came up with a system where the square root of -1 is defined as I, stands for imaginary. With that in mind, if you take the square root of a negative number, which normally you couldn't do, now there's a way you can simplify it because, for example, if you look at the square root of -4, well, you could look at this as the square root of 4 times the square root of -1, since 4 times -1 is -4. And then you can simplify it because the square root of 4 is 2 and the square root of -1 is I. So that would give you 2I. Now, no teacher wants you to have to split this up like this like every time you do it. So you want to get comfortable enough with it that you can just look at it and go, okay, if I have the square root of -25, if I ignore the negative sign for a minute, I'd have the square root of 25, and that would be 5. But I know if there's a negative under the radical, that's going to be I. So you just immediately go there. So if I said, what's the square root of -49? What would you say? Yeah, you would say 7I, just like that, without thinking about it very hard. So that's one level, one type, the simplest. Okay. Now, what about problems that don't simplify? Okay, for example, say if I have the square root of -13. Again, you could think of this as the square root of -1 times the square root of 13. The square root of -1 is I, but the square root of 13, there's nothing you can do with it, so it just stays the square root of 13. Now notice, when you have just a number and I, you put the I on the right hand side, 7I. When you have a radical and I, the I goes on the left, I radical 13. But again, I don't want you to have to, I really would encourage you to skip this middle step and go straight to this. Okay, so if I have the square root of -29, alright, 29 is a prime number, then that's just going to be I square root of 29. Okay, that I is, that negative under the radical becomes an I. Notice it's not negative at all. There's nothing negative about it. It just becomes I. Alright, so one more. Say if I have the square root of -41. 41 is a prime number. What's that going to be? That's right, I times the square root of 41. Okay, that leaves one more type of problem. Alright, so we looked at problems that were perfect squares, which simplified all the way. We looked at problems that didn't simplify at all, other than taking the I out. Now, what about problems that simplify partially? So for example, if I have the square root of -20, okay? So yes, this is the same thing as like I radical 20, right? But radical 20 can be simplified further. I'm just going to do that off to the side. Okay, the square root of 20, you know that that's the same thing as the square root of 4 times the square root of 5. So that's 2 radical 5. Okay, so just remember that. Okay, so back to this. Square root of 20 we just saw is 2 radical 5, so we need to do that. But that I just goes in the middle. Okay, so let's do that again. Say if I have the square root of -27. Okay, now the square root of 27 is 3 radical 3. But that negative is going to become an I in the middle. Okay? So that is how you simplify radicals. Okay, now we're ready to do problem number 1. We see that negative sign, so we know there's going to be an I involved. Ignore that for a minute and just take the square root of 40. Alright, the square root of 40 is 2 radical 10. So you know we're going to have 2 radical 10, but that negative sign is going to cause an I right here in the middle. So that's just plain the answer to number 1. Okay, now number 2 is a completely different type of problem. When we raise I to any power, like, I to the 341 power, or anything that you want to put on this I, there are only 4 possible outcomes. It will either be I, or it'll be -1, or it'll be negative I, or it'll be 1. These are the only 4 possible outcomes. Now let me teach you a little system for how you know which one of those 4 things it is. Start with this. It's going to either be I to the first power, or I to the second power, or I to the third power, or I to the fourth power. Okay, that's where each one of the 4 possibilities come from. Now, I to the first power, let me just switch colors for a second. I to the first power is just I. Okay, anything to the first power is just going to be itself. On the other hand, I squared, and this is worth memorizing, I squared is -1. Now, if you remember from earlier, I told you that I is defined as the square root of -1. So one way to think about this is to say, well, of course, if I were to square both sides, alright, we know that a radical and a square cancel each other out. So that would just leave me with I squared equals -1, alright, because these cancel out. So there you go, I squared is -1. But you should just memorize that. That's important. Now, if you look at I to the third power, I to the third power turns out to be -I. Now, the reason why that is, might as well erase this too. If you want to look at I to the third power, here's a way you can think about it. It may help you remember. I to the third power, you could split that up and think of it as I squared times I. Okay, right? Because altogether that would make I to the third power if you multiply it back together. So I to the third power is I squared times I. Now we just learned that I squared is -1. So that means this is the same thing as -1 times I. And of course we wouldn't really need the 1 here. -1 times I is -I. So that's why I to the third power is -I. Okay, and then there's I to the fourth power. Well, I to the fourth power is just 1. And here's why that makes sense. Whoa. Alright, here's why I to the fourth power is just 1. Because I to the fourth power is the same thing as I squared times I squared, right? Alright, because when you do exponents, I squared times I squared is I to the fourth power. But we just learned that I squared was -1. So this would be the same thing as -1 times -1. But a negative times a negative is a positive, so that's a +1. Okay, so I to the fourth power is +1. Now I'm mentioning all this because just in case you forget, that I to the third power is -I, or that I to the fourth power is 1, if you know that I squared is -1, then you can figure it out. Okay, so far we know this. Now, to finish this off, again, if I give you I to any random power, like I to the 237 power, we need a way of knowing which one of these 4 things it's going to be. Now, look at these yellow powers here. This will help us. There are 4 of these, okay? think of it as money, quarters, okay? If you have 1/4, how much money do you have? You have 25 cents, right? If you have 2/4, how much money is that? Well, that's 50 cents, all right, which is the same thing as 0.5 if you erase the extra 0. All right, if you had 3/4, how much money is that? Okay, well, that's 75 cents. And if you had 4/4, how much money is that? Well, that's $1 with 0 cents left over, okay? Now, how is this going to help us? Well, it turns out we can find these decimals if we are working a problem. If you look at the power, you can figure out which one of these it's going to simplify down to by dividing by 4. So if I take 237, for example, and I divide this by 4, okay, I get 59.25. Alright, focus on the 0.25 because that's the part that tells us which one it is. See the 25 cents, 1/4. Okay, the 0.25 tells us that this must be the same thing as I. Okay, so the final answer would simply be I. Okay, and that works for all of these. And just understand that if we're talking about I to the 4th power, it'll be I to the 4th power if we have no decimal. Okay? So looking at number 2, we have I to the 175 power. Well, so if I want to figure this out, I will start by doing 175 divided by 4, see what kind of decimal I'm going to get. Okay, so I get 43.75. Okay, it's the 0.75 is the part that we look at, and looking back at our chart, 0.75, that's negative I. So that's the answer is negative I. Alright, obviously once you have the chart it's easy, but the key is you have to be able to generate this chart the way I did from memory. So that's what you should practice. So right now you should pause the video, take out a blank sheet of paper, and see if you can draw this chart from memory. Okay? Start with the yellow part, then do the green part, and then do the money part. Alright, go ahead and pause the video and see if you can do that right now. Alright, and do it over and over again until you can do it easily. So the next time you have a test or something, the first thing that you do is just draw the chart in the margin of your paper, and then you can use it to answer the questions. Alright, take a look at number 3. We're supposed to find the discriminant and then talk about the number and type of solution. Discriminant. Alright, remember about the quadratic formula. This is the quadratic formula. If we have a quadratic equation in standard form, which is like this, now the part underneath the radical, b squared minus 4ac, has a special name. It's called the discriminant. So that's what we're dealing with now. Not the radical part is not included, just the b squared minus 4ac part. Okay, so first we need to put this in standard form before we do anything else. So we definitely want to subtract 5 from both sides, and so that'll give us 3x squared minus 7x minus 5 is equal to 0. Okay, so in this form it's clear to us that we have a is 3 and b is negative 7 and c is negative 5. So when we do the discriminant, which of course is b squared minus 4ac. Then we are doing negative 7 squared minus 4 times 3 times negative 5. Alright, so this is what it would look like if you typed it into a calculator, and we get 109. Okay, so the discriminant is 109. And so there's that, but we're also supposed to say the number and type of solutions. And here's the graphic organizer that helps us answer that question. If the discriminant is positive, we're in this situation and we have two real solutions. Okay, like for example, if I had a positive 16, that would turn into a 4, and I'm doing plus 4 and minus 4, and that gives me two different answers, 5 or 1. If the discriminant is 0, then that gives us this situation if we were to graph it. One real solution. The reason why is, imagine that we have 0 under the radical. Normally we get the two solutions by adding and subtracting this number. But adding and subtracting 0 doesn't really change anything. You can just get rid of the 0. So really you're just going to have the one solution, like this would be 3. If the discriminant is negative, you're in this situation graphically, no x-intercepts. So we don't have any real solutions, but we have two imaginary solutions. And of course the solutions will be imaginary because with a negative discriminant you have a negative under a radical, and we just learned that a negative under a radical is where we get I from. So we're going to get plus or minus 4i in this case, and that's going to give us two imaginary numbers. Okay, so to review, if the discriminant is positive, two real solutions. If it's 0, one real solution. And if it's negative, two imaginary solutions. So in this case, the discriminant was positive 109, so that means we're going to have two real solutions. Alright, let's move on to number 4 and 5. Solving using the quadratic formula. Okay, show your work, of course. Okay, so we need to know what A, B, and C are. So it looks like A is 1 because that's the coefficient. B is negative 4, and C is 8. So when you do the quadratic formula, the first thing you should do is the discriminant. Okay, b squared minus 4ac. So let's do that first. The discriminant is b squared minus 4ac. You know what, maybe I won't bother with that. Okay, so that means we're going to have negative 4 squared minus 4 times 1 times 8. And we don't really need the 1, but I'm just not leaving it out so you can see exactly where everything is coming from. And you should be able to do this without a calculator, but just in case you're one of the people that do need a calculator, here you go. Okay, notice the parentheses around the negative 4 squared. That's mandatory. If you don't use the parentheses, you will get the wrong answer. Okay, so you should be getting negative 16. Alright, so our discriminant is negative 16. Now we can go ahead and do the rest of the quadratic formula. Okay, and the rest of the quadratic formula, remember, looks like this. Alright, so it's opposite of b plus or minus square root, discriminant, all over 2a. So here we go. Opposite of b, so b is negative 4, so the opposite of b will be positive 4. Alright, and then it's plus or minus square root, and then under the square root goes the discriminant, so there's our negative 16, all over 2a. 2a is 2 times 1, which in this case will just be 2. Okay, Now let's simplify the square root of negative 16. We learned that before. The square root of negative 16 is just going to be 4i. Okay, again, the square root of 16 is 4, and anytime you have a negative under the radical, that's going to become an I. Alright, all over 2. Now, I'm noticing that we have 3 numbers here. All 3 of these are divisible by 2, so we should do that. Alright, I'm going to draw a heart around all 3 of these to remind me that it has to be all 3 or nothing. I could never just do 2. Alright, since all of these are divisible by 2, I'm definitely going to do that. So that's going to give me 2 plus or minus 2i. And that's the final answer. Okay, one more problem. I think, did I see? Oh, bonus question. Alright. Number 5. First thing, I need to subtract 15 from both sides. Okay, so that's going to give me 2x squared minus 7x minus 15 equals 0. That tells us that A is 2 and B is negative 7 and C is negative 15. So as before, the first thing we do is find the discriminant. Find b squared minus 4ac. So that's going to make negative 7 squared minus 4 times 2 times negative 15. Okay, so that's what it would look like. So that's 169. So that's our discriminant. Then you can go ahead and do the rest of the quadratic formula, which will be opposite of b. So b is negative 7, so the opposite of b will be positive 7. And then plus or minus square root, and you've got 169, all over 2a. 2a means 2 times 2 in this case, so that'll be 4. Alright, so we keep going. Square root of 69. Now that's a perfect square. If I do the square root of 169, that's 13. Alright, so what I have is x equals 7 plus or minus 13 over 4. Now do not leave it like this. Alright, 7 plus 13, 7 minus 13, these are just regular numbers that we can evaluate. So we need to do that. Okay, so if I do 7 plus 13 over 4, that's going to give me one answer. And if I do 7 minus 13 over 4, that's going to give me the other answer. 7 plus 13, that's 20 over 4, so that's 5. 7 minus 13, that's negative 6 over 4. Dividing both of these by 2 gives us negative 3 over 2. Okay, so these are the 2 solutions for problem number 5. Okay, if anybody needs this, please understand you could use a calculator at this point. 7 minus 13 over 4. If you're really bad at arithmetic, then just understand you could do 7 minus 13 over 4 like that and just get your negative 3 over 2. I'm hoping you don't need that, but I'd rather you use a calculator than get the wrong answer every time. Okay, alright, that leaves only the bonus. So let's take a look at that. Alright, well, we have I to the negative 47 power. Well, a negative power will drop you down to the denominator. So this is the same thing as 1 over I to the positive 47 power. Now, we learned how to simplify I to any power, so now we do that. And the way we learn to do that was to take this number and divide it by 4. So if I do 47 divided by 4, I get 11.75. Looking back at our chart, the 0.75 goes with negative I. So that means this is going to just become 1 over negative I. And that's as far as we can go. 1 over negative I. That's it. Alright guys, I hope this video was helpful to you. And if you actually took this quiz as one of my students, hopefully you understand any mistakes that you made. Either way, I will see you on the next video.